Hello students! The main objective of this lesson is to provide some background understanding of fire and explosion problems. The purpose is to provide basic information important to the safe handling of chemicals, in particular reactive chemicals and materials posing fire and explosion hazards. A hazard materials incident is a situation that may potentially leads to a catastrophic fire or explosion and human exposed to a toxic chemical. This situation may result from a spill of a hazardous material, a leak from a storage vessel, or the mixing of incompatible chemicals, whereby a chemical reaction could occur, resulting in the release of energy and generation of toxic byproducts.
Please study this safety vocabulary. You could fill this table based on this lesson. Take a picture of it.
The burning, palaminen, of a substance in oxygen is due to the rapid combination of substance or of the elements composing it with the oxygen. Combustion is the scientific word for burning. In a combustion reaction, hajoamisreaktiossa, a substance reacts with oxygen, forming one or more oxygen-containing products, often including water. In general, oxide is a compound of oxygen with another element. Water, vesi, for example, is an oxide of hydrogen. Hydrogen means water form. Dihydrogen monoxide is a rarely used chemical name for water. Carbon can form two oxides, namely carbon dioxide, hiilidioksidi, and carbon monoxide, hiilimonoksidi or HACA. The ordinary forms of fuel contain large percentages of carbon. On burning, this carbon combines with the oxygen in the air, forming carbon dioxide, hiilidioksidi. Carbon monoxide, hiilimonoksidi, HACA, is formed when air draft is insufficient. When inhaled, it combines with the hemoglobin, the red coloring matter of the blood, and in this way prevents the absorption of oxygen, so that even a small quantity of the gas may prove fatal. Combustion reactions are important because most of our society's energy is derived from them. Exothermic reactions, exothermiset reaktiot, are reactions that release energy, usually in the form of heat or light. The process is not simply the release of energy when bonds form, because the starting materials already have atoms bonded together. The two oxygen atoms in oxygen must be ripped apart, which takes a lot of energy, before new hydrogen-oxygen bonds in water or new carbon-oxygen bonds in carbon dioxide are formed, which releases energy. But as the energy released in the bond formations exceeds the energy required for initial bond breaking, the combustion will release energy as heat. In an exothermic reaction, energy is released because the total energy of the products is less than the total energy of the reactants. The combustion components are commonly graphically referred to as a simple fire triangle. The triangle illustrates the three elements a fire needs to ignite: fuel, oxygen and heat. Polttoaine, happi ja lämpö. For a fire to start, there must be a material to burn, and this is referred to as the fuel, polttoaine. Fuel is any kind of combustible material. Oxygen, happi, is needed as it reacts with the burning fuel. In order that a substance may undergo combustion, it is necessary that it should be heated to a certain temperature. Fire is initiated by a combustible material coming into contact with a heat source, lämmönlähde. Heat sources include the sun, hot surfaces, sparks, friction, and electrical energy. Fire safety is based upon the principle of keeping fuel sources and ignition sources separate. An international proverb says, "Fire is a good servant, but a bad master." Tuli on hyvä renki, mutta huono isäntä. The real cause of most accidents is what might be classified as human errors. Injuries can result from lack of procedures, poor facility design, working conditions, use of improperly designed tools, distraction, lack of skill and risk-taking. Safety achievement is a team approach. Everyone within an organization has certain responsibilities when it comes to fire safety. Adopt safe working practices. Follow workspace guidelines to ensure safety. Keep workspace and equipment clean, free of drips and spills. Follow rules for disposing of flammable wastes. Know and understand procedures concerning fire emergencies. Employers need to prepare for emergencies by making sure smoke alarms and fire sprinklers are properly installed and working. They should teach employees about exit locations, escape routes, and fire protection equipment.
Safety at work also starts from knowing and understanding the labeling of hazardous chemicals. Chemical suppliers are responsible for classifying the substances according to their hazardous properties. Hazardous chemicals that are placed on the market have to be properly labeled. If a substance is classified as hazardous and is also intended for professional and industrial users, the chemical supplier will also provide the safety data sheet, käyttöturvallisuustiedote, which is a document that lists information relating to occupational safety and health. You need to check both the labels and the safety data sheet for the chemicals you handle at work. Hazard pictograms form part of the globally harmonized system of classification and labeling of chemicals, the GHS. Globally harmonized means the same labeling applies throughout the world. Study the GHS pictograms. Know what each symbol represents. Here's the first one. Flammable, syttyvä.
Hydrogen, butane and methane are examples of flammable gases, syttyvät kaasut. Flammable gas, such as hydrogen, can react in an explosive manner when mixed with pure oxygen or air in the right proportions. When using a flammable gas, always be aware of the level of ventilation needed when burning the gas. Keep the area where you store the flammable gas ventilated and cold.
A flammable liquid, syttyvä neste, is a combustible liquid which can be easily ignited in air at ambient temperatures. The measure of a liquid's flammability is its flash point, leimahduspiste. The flash point is defined as the lowest temperature at which vapors above a volatile combustible substance will ignite in air when exposed to a flame. A liquid with a flash point at or below 60 Celsius degrees will be classified as flammable liquid.
Petrol or gasoline, benzene, is a fuel used in a spark ignition engine. To ignite, the fuel must have a low flash point. That is why under almost all conditions, gasoline evaporates to form an ignitable mixture with air. There is a cloud of gasoline vapor hanging above the surface of the liquid, and as gasoline vapors are heavier than air, they flow invisibly along the ground. When a spark or flame hits the vapor, it ignites. Never use gasoline around a flame source. Diesel is suitable for use in a compression ignition engine, where diesel is heated up by being squeezed, so a spark isn't needed for the combustion. Diesel fuels normally have relatively high flash point between 55 and 90 Celsius degrees. In practice, this means that diesel hardly gives rise to fire and explosion risks at normal outside temperatures. Those diesel fuels that have a flash point below 60 Celsius degrees are anyway classified as flammable liquids, others are classified as combustible liquids. What happens if you accidentally fill your diesel car with gasoline? It doesn't take very much gasoline to depress the flash temperature significantly, which can be dangerous. This means the fuel will ignite at the wrong time. Do not start the engine, even just to move the car from the pumps. That could cause expensive damage to the engine. The fuel tank will need to be completely drained and the fuel system flushed out. The flash point is not to be confused with the auto ignition temperature. The flash point is the temperature where the combustible material can ignite by an external ignition source. The auto ignition temperature, it's a syttymislämpötila, or the ignition temperature, is the minimum temperature at which a substance in air must be heated to cause self-sustaining combustion independent of the heating source. So this is the minimum temperature at which the material will ignite without a spark or flame being present. The auto-ignition temperature is higher than the flash point. Along with the values of flash point, it gives an indication of the relative flammability of the chemical. Spontaneous combustion, it's a syttyminen, is a type of combustion which occurs by self-heating and finally auto-ignition. Linseed oil, pellava öljy, is used for the protection and maintenance of wood. Rags soaked with linseed oil pose fire hazard because they provide a large surface area for rapid oxidation, which may lead to spontaneous combustion. The GHS defines a flammable solid as a solid that is readily combustible or may cause or contribute to fire through friction. Readily combustible solids are powdered or granular chemicals that can be easily ignited and the resulting flame spreads rapidly. For all flammable metals, reactivity increases with finer particle size. Copper does not burn, but finely divided copper powder may burn in air, and poisonous gases are produced in fire.
Okay, so now we know that the flame pictogram is used for flammable gases, aerosols, liquids and solids. But do not confuse the flame pictogram with the flame over circle pictogram. The flame over circle pictogram is used for oxidizing gases, liquids and solids. Oxidation reduction reactions, hapetuspelkistysreaktiot, or redox reactions, are reactions in which electrons are transferred from one reactant to the other. Many redox reactions involve the reaction of a substance with oxygen. However, redox reactions need not involve oxygen. So, a fundamental definition of oxidation is the loss of electrons, and a fundamental definition of oxidizing agent is a substance that causes the oxidation of another substance. Anyway, the dangerous goods definition of an oxidizing agent, hapettava, is a substance that can cause or contribute to the combustion of other material. Oxidizing chemicals readily give off oxygen or other oxidizing substances, such as the halogens like bromine, chlorine, or fluorine. Keep oxidizers away from other chemicals, especially flammables and combustibles. Store oxidizing substances in dry, cool areas, out of direct sunlight and away from other sources of heat. You should read the safety data sheet for a substance, because it is very important to know the best ways to fight fires involving oxidizing chemicals. Methods based on smothering are often ineffective, so cooling with large amounts of water might be a suitable method, but some oxidizers are water reactive, and water on fires involving water reactive oxidizers can lead to violent explosions.
Oxygen is an oxidizing agent. Oxygen combines chemically with the other material in a way that increases the chance of a fire or explosion. Oxygen makes other things ignite, but oxygen itself does not catch fire. Common uses of oxygen include welding and cutting of steels and other metals, and use as a medical treatment, and life support systems in aircraft and diving. As you remember, oxygen is the key ingredient in the fire triangle. The air is only about 1/5 oxygen, the remaining 4/5 being inert, i.e. unreactive gases. Not only is less oxygen available, but much of the heat is absorbed in raising the temperature of the inert gases surrounding the substance undergoing combustion, and the temperature reached in the combustion is therefore less. Things ignite at a lower temperature and burn hotter near purified oxygen. Even substances which burn in air with great difficulty, such as iron, readily burn in oxygen. And anything that can burn will burn much faster in an oxygen-rich environment. When there is approximately 21% oxygen in normal air, just 30% oxygen in the atmosphere will cause things to burn 8 times faster. Combustion in air and oxygen differs only in rapidity, the products formed being exactly the same. So remember, fire and burns can result from misuse of oxygen, and oxygen must be handled with care. Always have a fire extinguisher ready for immediate use. Many people are injured each year by the incorrect use of oxy-fuel gas equipment. Oxygen gets misused, for example, when it is used to blow dust off clothing or work areas. Never do that. The oxygen will remain present in the cloth fibers. Even fire-retardant clothing contaminated with oxygen will catch fire easily and burn very fiercely. Oxygen is the primary cause of most hospital fires. Remember that oxygen should never be used near anything that can produce heat flames or sparks. Even if the oxygen is turned off, the building is vulnerable. If you work with medical treatment of patients with oxygen generators, it is important to learn to use oxygen equipment safely. Do not use oil or any other flammable substance on oxygen equipment or on skin near the equipment. This compound is called hydrogen dioxide or hydrogen peroxide. The prefixes di and per signifying that it contains more oxygen than hydrogen oxide, which is the chemical name for water. Solutions of hydrogen peroxide are used largely as oxidizing agents. Its use as an antiseptic depends upon its oxidizing properties. Hydrogen peroxide gradually decomposes at room temperature to produce oxygen gas and water. When it decomposes, large amounts of heat are liberated, leading to an increased rate of decomposition, since decomposition is accelerated by increases in temperature. Hydrogen peroxide is a strong oxidizer because oxygen released in decomposition will promote combustion. It will accelerate burning when involved in a fire. Avoid contact with combustible materials such as organic materials. Hydrogen peroxide solution should be kept in a dark, cool place, since both heat and light aid in the decomposition of the dioxide. A solution of hydrogen peroxide decomposes more slowly when it contains a little phosphoric acid than when perfectly pure. For this reason, commercial hydrogen peroxide contains phosphoric acid. Solutions of 8% or higher hydrogen peroxide in water must be stored with specially vented caps. The properly working vent will prevent the buildup of pressure inside containers. Chlorine is one of the most active of all elements and a strong oxidizing agent. Chlorine has germicidal properties, and the free element as well as compounds from which it is easily liberated are used as disinfectants. Chlorine can be used in the form of sodium hypochlorite to kill microbes in drinking water supplies and public swimming pools. Okay, Let's talk about explosions then. Puhutaanpa räjähdyksistä. A hazardous area can be defined as a place where there is a risk of an explosion. It is a location in which an explosive atmosphere may occur and where special precautions over sources of ignition are needed. Hazard signs must be displayed to warn people to be careful. Many substances form an explosive atmosphere with air. Explosion of gas or vapor is possible when the ambient temperature becomes greater than the flash point of the flammable material. That's why explosions happen when hot work is done in a location where flammable vapors exist. For example, welding on a tank that had been used to store a flammable liquid such as gasoline can cause an explosion. Many common materials which are known to burn can generate a dust explosion, such as coal and sawdust. Powdered metals can become explosive if broken down into dust that is suspended in air. In situations where an explosive atmosphere may occur, one must use equipment with a low probability of creating a source of ignition. Equipment built to the requirements will carry the explosion protection symbol EX in a hexagon. Can you explain why fires near sealed gas cylinders are extremely dangerous? Remember that molecules of a gas move randomly. If you heat a gas, you give the molecules more energy, so they move fast. If pressure is kept constant, then if the temperature of a gas is increased, molecules begin to vibrate and move more, creating more distance between themselves, and the volume of the gas increases. But when a gas is trapped inside a container which has a fixed size, fast-moving particles will collide with the container walls more frequently. This means an increase in the pressure. So, the pressure in a gas cylinder will increase when subjected to increased temperatures. If the cylinders heat up enough, they can explode.
The globally harmonized system GHS defines gases under pressure, painanalaiset kaasut, as gases that are contained in a receptacle at a pressure of 200 kilopascals or more, or which are liquefied and refrigerated. Gases under pressure will be identified with the pictogram shown. The pictogram is a gas cylinder, kaasupullo. Cylinders are designed with the pressure relief valve, paineenalennusventtiili. Still, they may explode if heated. Great care should be taken in the use, storage and handling of these cylinders. It is important to remember that the product may have other hazards depending on the properties of the gas. It is very important that you read the label carefully before use. The refrigerated liquefied gas may cause so-called cryogenic burns or cold burns that are tissue damages caused by freezing. Protective gloves and eye protection must be worn at all times when handling for example, liquid nitrogen.
A pressure regulator is a valve that controls the pressure to a desired value. All compressed gas cylinders must be used with a regulator that is designed for the gas and pressures involved. A cylinder containing compressed gas can shoot through the air like a rocket if its valve is damaged. It can accelerate to speeds great enough to penetrate concrete walls. Maintain proper gas pressures and maintain all equipment and regularly check its condition. Regularly check all connections for faults and leaks. Turn the gas supply off at the cylinder when the job is finished or before the cylinder is moved.
Storing gas cylinders in a workplace poses risks. You need to make sure they are kept away from physical damage, not exposed to heat or the direct rays of the sun. Store cylinders, both empty and full, in an upright position and protect cylinders from falling. Secure with an insulated chain or belt. Protective caps should be kept in place and secured. Store cylinders in a well-ventilated place, away from flammable and combustible materials such as oil. Store oxygen cylinders and fuel gas cylinders separately.
Before moving a cylinder, install the cylinder cap. Use a cylinder trolley designed to transport cylinders. Allow very little movement when transporting.
The exploding bomb pictogram appears on the chemical labels of substances that are explosives, RÄJÄHDE. An explosive, RÄJÄHDE, is a solid or liquid chemical which is in itself capable by chemical reaction of producing gas at such a temperature and pressure and at such a speed as to cause damage to the surroundings. Explosive properties are associated with the presence of certain chemical groups in a molecule which can react to produce very rapid increases in temperature or pressure. In Finland, explosives may only be purchased and used by a person with a certificate of competency of panostaja. Some fireworks, ilotulitteet, are allowed for consumers of legal age. Most dangerous fireworks are allowed for professional use only. If you store explosives, you will need a license unless you store just very small amounts of fireworks. When storing fireworks at home, the main things to ensure are that the fireworks are kept away from any sources of heat and that the fireworks are kept dry. Wear appropriate protective eyewear when handling fireworks. Never smoke around the fireworks.